Hello everyone. Today we're looking at the problem maximum possible number by binary representation. This was question 1 in weekly contest 418. So the question reads that we're given an array of integers nums, which will always be of size 3. We want to return the maximum possible number whose binary representation can be formed by concatenating the binary of these elements in some order, and that the representation does not contain any leading zeros. So an example is that we're given nums of 1, 2, and 3, and the output would be 30. And the explanation is that if we look at the binary that these numbers form, we can concatenate them to get this number, which when we convert to an integer will give us 30. Let's take a closer look at this example and see exactly how we can solve this. So looking at this same example, we can maybe try a couple different things. So what if we were to, first of all, let's look at the binary of each of these numbers. So for 1, we just have 1, right? Pretty simple. For 2, we would have 0, 1. And for 3, we would have 1, 1. Okay, so now really what we can do is we can just try all the combinations. There may be like a smarter way to do this. Maybe we can try to think about maybe the most number of ones can come first, but it's kind of overkill for this problem. This is just a brute force solution. We can just try out all the combinations. So for example, let's try out 1, 0, 1, 1, 1. This represents 1 here, 2 here, and 3 here. So we know this is not our answer, so we can move on. Let's try 2 first. So we can try maybe 2. We could try 3 and then 1. We know this isn't our answer either. Then we can try maybe 3 first, so 1, 1. Then we could try 1, 0, 1, right? So what you see is that we're really just trying all the different combinations. So there's not much to explain here. We just want to be able to convert all these numbers to binary, try all the combinations, and just return the maximum one that we find. So the interesting thing here is the time complexity. So let's think about this. So what are we actually doing? Well, to convert our numbers to binary, we'd have to go through potentially all the bits in these numbers. But the maximum value we can have in any of these numbers is 127. And what is 127? Well, 127 is the maximum value we can have for a 7-bit number, right? So each of these values will have 7 bits. So you can see we'll do 7 times 3. So we have to do 21 units of work in order to convert these numbers to binary. Then what we're doing essentially is we're trying out all these different combinations. And you see we have 3, and we could potentially do these 3 in a number of permutations, right? So we could do 3 to the n permutations essentially, or 3 factorial permutations of these numbers. So one thing you'll see here is that I'm not using n or m notation at all. I'm speaking strictly in numbers. And why is that? Well, because these will always be a fixed size, right? So we're always going to be converting all 7 of these bits and going over them. We're always going to try the same number of permutations. So while we are doing work, technically it's constant, right? Because no matter what we're given, we always know that the amount of work we're going to do is the same. We're always going to have to go over 7 bits for each digit. We're always going to have to go over this many of permutations, right? So even though we are doing this work, it's not impacted by our input really at all. We can consider this to be an O of 1 problem. Let's hop over to the code and see exactly how this works. So the first thing we do is we want to just convert our nums array into a format that we can use. So what we're doing here is we're taking each number and converting it to binary. Then what we're going to do is keep track of the maximum that we've seen, and we're going to have 3 for loops to go through all of our permutations. And what we're doing in this line here is we're saying if any of these indices are the same, then I don't want to check this, right? Because I only want to try combinations or permutations where each is its own unique index. I don't want to have any where I can duplicate. That's not part of this problem. So if at any point either I and j or I and k or j and k are on the same index, we just continue past this because we know that it is not a valid case that we can check. Then what we do is we update our maximum with either whatever we currently have or whatever that concatenation is of those binary values with base 2. Then at the end, we just return our maximum value. So let's submit and make sure that this works. And it does work. So hopefully this was helpful and you enjoyed the video, and thank you for watching.